Hi friends, today we're going to talk about graphing by plotting points. So, when we have something that looks like y equals or f of x equals, that means the same thing, but either way it tells us a rule of how to calculate y when we have x. Now, for example, this could be y equals x plus 2, or it could be f of x equals x plus 2, but keep in mind, those are the same thing. It's just our rule for how to calculate y. So anytime you have a function that you'd like to graph, we can use this rule to find enough points to graph it. Now you're going to learn several ways to graph lines and quadratics, but this is the method that will work no matter what y is or f of x is. For this video, I'm going to use y, but just know that those are the same things. So for example, if my rule was, as we said, y equal x plus 2, we could start with a table. And this table would give us the points we wanted to plot. So I'm going to create a table, and I'm going to do a column for x. I'm going to do a column for y, and when I write y, I'm going to go ahead and write that rule, x plus 2, and then the third column of my table is going to be the point on my graph that I want to plot. Now, we can choose x to be anything we want, anything we want. We don't get the same choices with y, but for x it can be anything I want. But I want to make smart choices. So for this one, I'm going to start with -2 to 2. So in my x column, I'm going to write the numbers -2, -1, 0, 1, and 2. I'll use that rule of y equals x plus 2 to find y. And I'm going to go ahead and write it out here. So when x is -2, y will be -2 plus 2, which is equal to 0. And then on the same row of my table, I'll write the point we just found, which is x equals -2, y equals 0. And I'm going to use that point when I'm ready to draw my graph. Let's go to the next row where x is equal to -1. So y is -1 plus 2, which is equal to +1. And I'll go across that row to fill in the point, -1, 1. We'll keep going in the same way. And when x is equal to 0, I have the point 0 plus 2 is equal to 2. That gives me the third point, x equals 0, y equal 2. And I'm going to go ahead and fill in. When x is 1, y is 1 plus 2, which is equal to 3, which gives me 1, 3 as a point. And when x is 2, y is 2 plus 2, which is 4, and that gives me the point 2, 4. So if you notice, all down this column, I'm going to circle those x values. Notice they all went in the same position x was in my rule. All right, let's graph it. So to graph it, I'm going to start by drawing a horizontal line with arrows on both ends. I'm going to label that x, and I'm going to draw a vertical line right through the middle of that with arrows on both ends, and I'm going to label that y. And the point where they intersect, I'm going to put a little 0 next to it because that's the origin. I'm going to mark tick marks on the axis from the origin, about 5 in each direction, so that I can plot all of my points on this graph. All right, so let's start plotting our points. The first one is the point -2, 0. So in the x direction, I'm going to go -2. So that -2 goes to the left of the origin. So I'll go negative 2 in the x direction, 1, 2, 0 in the y direction, so that means my point will just sit on that x-axis. The next one is the point negative 1, 1. So I'll start at the origin, I'll move negative 1 to the left, and up 1 to plot my next point. Next, I have the point 0, 2. So I'll go 0 in the x direction, so I won't move left to right, but then I will go 2 up to plot that point. My next point is 1, 3, so I'll start at the origin. I'll move 1 to the right and 3 up and put a point. And then the last one is the point 2, 4. So starting at the origin, 2 to the right and 4 up. I'm going to connect those dots with a straight line. I'll put arrows on both ends, and I like to label my graphs y equal x plus 2. All right, so this method works no matter what y is. There's any way that we can define that rule, we're going to use the same series of steps. So let's write out what those steps are right over here. So first thing we're going to do is solve for y. That was already done for us in this problem, but if it wasn't, we would go ahead and do that. And we would use our rules to get y all the way by itself on one side. The second thing I'm going to do is I'm going to set up an xy table. And then after I have that, I'm going to choose x values. And remember, we can choose anything, but we want to make smart choices to make our life easier when we solve for y. All right, my fourth step is I'm going to plug in the x values to get the y values. Remember, y is our dependent variable, and it depends on the x value. Fifth step, we're going to plot those points on the graph. And then finally, we're going to connect them up. All right, let's try another example. Start one right up here. All right, this one, our y value is not going to be all the way by itself yet. So x plus 2y is equal to 6, and my instructions would say graph it. So for step 1, we need to solve for y, because y is not by itself already. So I'll subtract x from both sides. I can rewrite this as 2y is equal to 6 minus x. We'll divide by 2 to get y all the way by itself. So y is equal to 3 minus x over 2. And another way we could have written that is y is equal to negative 1/2 x plus 3. I feel like that form looks a little friendlier, so I'm going to leave it in that form. Let's set up our xy table. So I'm going to have a column for x, column for y, and I'll write that rule down, negative 1/2 x plus 3. And then we'll have a column for our points that we find. Now in this one, we want to choose our x's carefully so that we don't end up with fractions. So all of my x values are going to be divided by 2. It makes sense to choose x values that are going to be even numbers so that when we divide them by 2, we get a whole number and not a fraction. So I'm going to start with negative 2. I'll use 0, 2, and 4. And those are reasonable x values that will give me whole numbers. Let's plug them in. So when x is negative 2, y is negative 1/2 times negative 2 plus 3. Well, negative 1/2 times negative 2 is just positive 1, and 1 plus 3 is 4. The point when x is negative 2 would be negative 2, 4. All right, let's plug in x equals 0. Negative 1/2 times 0 plus 3. Well, anything times 0 is 0, and 0 plus 3 is just 3. When x is 2, I have negative 1/2 times 2 plus 3. Negative 1/2 times 2 is negative 1. Negative 1 plus 3 is just 2. I think we see a pattern happening here. And when x is equal to 4, I have negative 1/2 times 4, which would be negative 2. Negative 2 plus 3 is 1. All right, so the points that we found were negative 2, 4, 0, 3, 2, 2, and 4, 1. So let's draw a graph. Again, I'm going to draw that horizontal line and label it x, and vertical line and label it y, and I'll label the origin. And again, I'm going to put tick marks out 5 units in each direction. Let's plot those points. So my first one is negative 2, 4, so negative 2 in the x direction, 4 in the y direction. 0, 3, so no movement in the x direction, 3 in the y. 2, 2, so 2 units to the right on the x-axis and 2 units up on the y. And then 4, 1, so 4 to the right and 1 up. I'm going to connect those dots. We'll pretend that line is straight. And I'm going to label it as y equals negative 1/2 x plus 3. All right. Let's look at one that's a quadratic. Sometimes a quadratic looks a little more complicated, but really we're just going to approach it the same way. So my example here is going to be y equals x squared plus 2x minus 3. Now I don't have a fraction, so I don't have to be super careful about the x values that I choose, and it's already solved for y. So we can just jump to that xy table. I'm going to leave myself a little more room though because my y is slightly more complicated. So my first column is x. My second column, I'm going to go ahead and write that rule. Y equals x squared plus 2x minus 3. And then my third column will be my points. Now I know that this is a quadratic because of this exponent of 2. And that tells me that my graph is going to be a parabola. So remember that looks like kind of a U shape. And a parabola requires more points to be able to see the whole shape. We want to be sure that we can see it come down and go back up on our graph. So let's start with negative 2 to 2. And remember, we can always adjust as needed if we need more points. So each of those x values I'm going to put into the rule for y. So when x is negative 2, my y value would be negative 2 squared plus 2 times negative 2 minus 3. Now remember, negative 2 squared is going to be positive 4. So I'll have positive 4 minus 3, which gives me a y value of negative 3. So the point when x is negative 2, y would be negative 3. All right, let's look at x equal negative 1. So y would be negative 1 squared plus 2 times negative 1 minus 3. Negative 1 squared is just 1, plus 2 times negative 1 is negative 2. So 1 minus 2 is negative 1, minus 3 is negative 4. And the point when x is negative 1 would be negative 1, negative 4. All right, when x is 0, we have 0 squared plus 2 times 0 minus 3. That's just going to be negative 3. And when x is 1, I have 1 squared plus 2 times 1 minus 3 would be 0. And finally, when x is 2, 2 squared plus 2 times 2 minus 3. So 4 plus 4 is 8, minus 3 is 5. All right, we have 5 points. Let's plot them and see if that's going to be enough points to see what the graph is doing. Again, I'm going to start by drawing in that horizontal line, and I'm going to label it x. And then a vertical line right through the middle of that I'll label y, and where they intersect, I'll label that the origin. And it looks like marking this one out, 5 in each direction is going to work. Of course, if your graph was shifted, you'd need to mark off further. All right, let's put these points up here. So negative 2, negative 3 would be 2 to the left and 3 down. I'm going to put a point right there. Negative 1, negative 4 would be 1 left and 4 down. 0, negative 3, no change in the x direction, but straight down 3 in the y. 1, 0, we have 1 in the x direction and 0 in the y direction. And then finally 2, 5. Let's see, 1, 2, 3, 4, 5 up. Now you can tell that we have a parabola, because if I connect these points, you can see it go all the way down and start to come back up. I might need to plot a few more points to see the whole thing, but if you're pretty comfortable with what a parabola looks like, it helps and you can fill in the rest of that graph. Okay. One more example I want to look at, and that is, what if I had something like y equals negative 3? There's no x's. So I can choose any x I want, but no matter what x I choose, y is negative 3. What would that xy table look like? So let's say I chose my x values to be negative 2, 0, and 2. Well, I can't plug an x in. There's no x to plug into that y rule. So no matter what x is, y is going to be negative 3. So guess what we found? We've got a horizontal line. So when I write down those points, I have negative 2, negative 3, 0, negative 3, and 2, negative 3. No matter what x is, y is negative 3. So I'm going to draw a graph here. Again, I have that x and y axis. Horizontal line that I've labeled x, and a vertical line right straight through the middle labeled y. And we can plot the points that we found on this graph. And you notice they are going to form a horizontal line, y equals negative 3. So watch out for those kind of tricky lines where there's a rule, but it doesn't involve your x value. No matter what kind of rule you're given, you're going to be able to use plotting points to find a good graph for that.